Hello guys, welcome back to Priyanka's tutoring classes. So today we are going to continue with module 2, which is vector calculus and which is for second semester students. So today's topic is show that f vector is both solenoidal and irrotational. This example is very important in the point of your sem and exams. So let's understand how to solve this. So when they ask you to show that this f vector is both solenoidal and irrational, you have to prove it. So how are you going to prove it is solenoidal? You are going to prove it is solenoidal by divergent of f vector is equal to 0. And how you are going to prove that it is irrotational? You are going to prove it by curl of f vector is equals to 0. So if you want to just solve the questions based on divergent and curl, I have already made a video based on that. So in this video, we will just understand how to prove f vector is solenoidal and irrational. So let's start with solenoidal. Okay. So first, before that, we'll write down the equation. What is given in the question? What is the equation? X I vector plus yj cap divided by x square plus y square. This is your f vector. Okay. So now what we'll do, we'll just separate the x terms and the y terms. How will we separate? We'll separate x I cap divided by x square plus y square plus, here we'll write y j cap divided by x square plus y square. So if you plus this, you will get the same f vector back. So this is how we are going to separate it. Now what we will do? Now we will solve it for solenoidal. So to prove that, I have written down the f vector as it is. And what is the formula of divergent f? Divergent of f vector is grade of f vector. So now, what is the formula of grade? Grade formula is dou by dou x I plus dou by dou y j plus dou by dou z k. Now I have written only the formula for grade. How am I going to write the f vector? What I am going to do is, see now, dou by dou x, instead of I am going to write the complete I term of the f vector. So how it is going to come? Dou by dou x in the bracket xi divided by x square plus y square plus now dou by dou y, and instead of j we are going to write the j term, that is y divided by x square plus y square. Now we can write dou by dou z also, but we don't have any z term here. So it is going to be 0 itself and it will be not having any meaning. So I am not going to write it down here. Now you have to differentiate this. See, normally what we do, we only differentiate one term. But here what we have it in the form of numerator and the denominator. When you are solving this, you have to use this formula. Okay. So your formula is v dou by dou x of u minus u dou by dou x of v divided by v square. Here your upper term is u. Okay, listen to this carefully. Your upper term is u, your denominator is v, down part is v, upper part is u. Now how will we solve this? I will show you. See, first what are you going to write? You are going to write v as it is. So what is v? X square plus y square. Now dou by dou x of u is nothing but differentiation of the u term. So differentiating x with respect to dou by dou x, it is going to be 1. Okay. 1 minus, now you are going to keep u as it is. What is your u? It is x. So now differentiation of v. Now what is your v? Your v is x square plus y square. You have to differentiate with respect to x. So x square becomes 2x. And because there is no term here, it becomes 0. Okay. Divided by v square. Your v square is x square plus y square raised to the whole square. So I hope this part is clear. Even if it is not clear, listen, I'll explain it once again for this term. Now here what you're going to do is, we had x for x term. Now when you have y, this formula becomes y. Okay. So this is y. This is y. We will solve. I'll show you how to solve it. So v is x square plus y square will be like that only, and differentiation of u with respect to y. After you differentiate y with respect to y, it becomes 1 minus u, that is y will be as it is, differentiate v. Now after differentiating c, x square is at least 0 plus y square becomes 2y. Okay, so divided by x square plus y square the whole square. So this is how we have differentiated this with respect to x and this with respect to y. What you have to do, you have to keep the v as it is, differentiate u, minus u as it is, differentiate v, divided by v square. Okay, so this, now what we are going to do, we are going to combine this and write. So we have x square plus y square minus 2x square, okay, plus x square plus y square minus 2y square divided by x square plus y square the whole square. So I will simplify this further. So this is what we got after differentiating. Now what you are going to do, we will just remove the bracket, then it becomes x square plus y square minus 2x square plus x square plus y square minus 2y square divided by x square plus y square. Now x square and x square becomes 2x square, y square and y square becomes plus 2y square minus 2x square as it is minus 2y square as it is divided by x square plus y square as it is. 2x square minus 2x square plus 2y square minus 2y square, 0 by x square plus y square. 0 by anything is equals to 0. Therefore, divergent of f vector is equals to 0. Hence, it is solenoidal. Solenoidal. I hope this is clear. I hope you have understood each and every part. If you have not understood, you have to learn normal differentiation. If you understand that, then you can solve this. So now let's solve the next part, that is irrotational. So for solving irrotational, I have written down the f vector, and to prove that it is irrotational, you have to prove that curl f vector is equals to 0. So first what you had, it was dot product, and now you have cross product. See, you have to have the cross product of grade and f vector. So this is grade and this is f vector. Now how we are going to do is, you have to write I, j, k. Okay. And then you have to write I components of grade, that is dou y dou x, dou y dou y, dou y dou z. Then you are going to write the I, j, k components of f vector, that is x divided by x square plus y square and y divided by x square plus y square. Here it is 0 because we don't have k vector. So to solve this, I'll tell you, this is plus, this is minus, this is plus. Keep this in your mind. What you have to do, you have to hide the first row and the first column. Okay. Then we get only this two remaining. So dou of dou y of 0 is 0 only, and see, dou of dou z of y divided by x square plus y square. Since there is no z term here, this also becomes 0. I vector plus, not plus. So you have to see the sign here. Here it is minus. And then now what you have to do? You have to hide the middle column and the upper row. Then you get this both into this both. See, now dou x of dou by dou x of 0 is 0 only. So it is again 0. And dou of dou z of this, here also there is no z vector, hence it becomes 0. And this is j cap plus, here it is plus. Now we are going to hide the last column and this thing. Now we get this both. So let's write this down. Dou by dou x of, what is here? Y divided by x square plus y square minus dou by dou y, and here it is x divided by x square plus y square of k vector. K cap. Okay, so this is what you got after solving. So let's solve this further. So this is what we found after cross multiplying. Then we'll solve this further. So this is 0 I, this is 0 j. We have to only solve this part, and this part how we will solve, when I showed you that formula right in the previous video, u by v. You have to use that formula and differentiate that. So k vector is as it is. First we will write v. So what is your v? X square plus y square. Differentiate this with respect to x. It becomes 0 minus. Then you are going to keep the u term as it is and differentiate this with respect to x. Then we get 2x divided by x square plus y square the whole square. Okay, and then here we have minus. Then we'll keep the v as it is, x square plus y square. If you differentiate x with respect to y, it becomes 0 minus. Then we keep x as it is, and then if you differentiate this with respect to y, it becomes 2y divided by x square plus y square the whole square. Let's solve this further. Then k cap is equals to, this becomes completely 0. We are left with minus 2xy divided by x square plus y square the whole square, and minus, here it becomes 0. We are left with minus 2xy divided by x square plus y square the whole square. Now k cap, see, we'll remove this thing, brackets, then it becomes minus 2xy, minus minus it becomes plus 2xy, and then x square plus y square the whole square. Now see, minus and plus get cancelled, it becomes 0 k cap, and then what we had, 0i plus 0j. Now we got 0 k cap. So in total it is equal to 0. Therefore curl of f vector is equals to 0. Therefore it is irrotational. Okay, so I hope each and every point is clear. If you want to prove it is solenoidal, you have to prove divergent of f vector is 0, and if you want to prove it is irrotational, then you have to prove curl of f vector is equals to 0. If you have any doubts regarding any step, you can even watch my previous videos where the basic is taught, or you can put them into the comment section and make sure I'll reply to it. And don't forget to like the video, subscribe the channel and share it to all your friends. Thank you.